I guess I'd like to start by talking about why is dust collection and dust control important in woodworking shop. So I think the answer is pretty obvious. Nobody likes to work in a dusty shop where you have accumulated dust on the floor, on surfaces, you're breathing it in, it's very uncomfortable, right? So pretty clearly, dust collection is critical just for a comfortable working environment when you're in a wood shop. Depending on the size of the shop, if it's anything bigger than like a garage hobby shop, you also have some regulatory requirements. So you have your OSHA requirements, and then you have NFPA, which define all the requirements for combustible dust. And if you have a wood shop, basically it's pretty well guaranteed that you fall under the NFPA 660 and 664 requirements for combustible dusts, because wood is combustible dust. So you have to comply not only with OSHA's general duty clause and all the OSHA requirements for dust collection and combustible dust, but you also need to be aware of NFPA and make sure that you have the right safety devices and controls in place for your wood shop. So that's regarding combustible dust. And then we want to talk about just, how do you make sure that the dust collection is sized right, set up right, and functions correctly and make sure you have a comfortable and safe working environment. So moving on to the next slide here, woodworking industries, we've worked with all kinds of different wood shops, basically from small high school type wood shops with a single, very small collector, to military installations. We just finished several big projects and we're in the process of completing several projects with DLA and Marine Corps logistics-based box shops. So these guys are doing basic woodworking, saws and drill presses and the like, cutting and fastening lumber into crates and boxes. So big dust collection systems in place. We've also worked with cabinet shops, all kinds of stuff. So any type of woodworking from really rough machining and milling to more finely engineered wood products where there's a lot of polishing, sanding, generating finer dusts. Kitchen cabinets, furniture, all that kind of stuff all falls under the rubric of woodworking shops. And the dust collection system approach varies a little bit depending on the type of processes that are in the shop, but overall the approach is similar. We may adjust some things based on the materials, if we're working with hardwoods versus softwoods or engineered lumber. If we're talking about collecting heavy chips and things like that versus very fine, light dust, that might inform our decision on how we size the dust collection system, the ductwork, maybe some filter media decisions, but overall the approach is pretty much the same. So on this slide here, you can see kind of a general wood shop. So you have a dust collector or a couple of dust collectors. We have ductwork that pulls the collected dust from the processes. So you might have chop saws or miter saws, panel saws, polishing stations, all these places where dust is being generated. You have collection hoods at each of those process pickup points. And then you have engineered ductwork, which is sized and designed to pull that dust out of your shop and out of that process through the dust collection system using a system fan or blower, and then exhaust clean air either outside of the facility or, and we can talk about this a little more later, or potentially recycle it back into your facility to maintain pressure in the building or to help lower your heating and cooling costs. So that's kind of a general wood shop you see there, pretty typical elements that we'll commonly see. So again, common processes may include milling, joiners and planers, cutting, sawing, drilling. Basically, anytime we're making chips or sawdust in a wood shop, sanding and filing. So all these processes are pretty common. They'll depending on the process, might change our approach to sizing of the hoods and the ductwork next to those processes, but overall, it all feeds into the same type system design. Size of wood dust is important. So you've got your class one light fine dust. So if you're doing sanding and polishing, what happens is the dust is much lighter. You get airborne dust, tends to kind of fill the shop air space if it's not collected properly. and it also has a much lower required velocity through ductwork potentially. So when you're talking about making sure that your dust flows properly through your ductwork, it's important to understand what class of dust you have. If you've done a dust hazard analysis, you probably have some data on the bulk density of your dust, maybe a mix. But in any case, it's important to know so that you make sure you have enough velocity through your ductwork and you also have the right filtration system in place. If you're doing a lot of or only light and fine dust, maybe you don't need something like a cyclone pre-separator upstream of your baghouse. But if you're doing a lot of class three, big fibers and strips and chips and things like that, it's probably more efficient to have a cyclone or something like that in your dust collection system. So those are some of the things that we think about. Um, System design considerations. So when we look at designing a dust collection system, again, we'll look at the dust type and size, fine versus big bulky dust and chips and so forth. We'll look at moisture content, and this may be, normally is not a huge factor when we're talking about wood shops, but it can be if you have a lot of moisture that can impact the filter media. We would want to know that up front. Um, Presence of other materials, plywood and particle board. I would say even more important would be like nails and staples and things like that. If they have a potential to make their way into your dust collection system, it's very important that we know that up front when we go to design the dust collection system. Application or machinery, we design a system starting with every single pickup point. So that's every machine in your shop. We would do a layout and we want to start by identifying the size and type of pickup points so we can start sizing the ductwork and eventually sizing the whole dust collection system. Intermittent or continuous duty, and I think we'll talk about this a little bit later. So most wood shops are not operating with every machine working 24/7. You use your uh, panel saw to make a few cuts typically, and then you'll move over to the miter saw, and then the panel saw sits idle for a while. That's more typical to the way a wood shop works. However, typically our approach would be, and this is in line with industry best practices, to assume that all of the pickup points are open at a given time. And then the intermittent continuous use, you'd use blast gates and a VFD on your fan, depending on how complicated your system is to adjust your system for balancing. Volume of dust is important. We want to know how much dust is being captured by your dust collection system so we can appropriately size the baghouse or cyclone if we're putting one in there, so we don't overload the dust collection system. Material handling, oftentimes in wood shops, the dust we collect just goes into drums or sacks or dumpsters just to get disposed of. And that's pretty simple to do. However, there's other things you can do. You can collect that dust and you can move it into a silo or some other process through material conveying systems for recycling or reuse or some other part of your process. We would want to know that up front so we can design that into your system as well. Total cost of ownership is an important concept. Basically, that means, more than just the upfront price tag for your system. What's the total cost over the long-term life cycle of the dust collection system? So we may, spend a little more on a VFD for your fan up front, for example, which may save you energy costs over time and result in a lower cost of ownership. Things like that we want to look at. We look at the whole system in the long term to make sure that it's the best, most efficient system at the lowest total cost of ownership over time. And then, of course, we've got the combustibility factor, and we'll talk about that on the next slide a little bit. So if you go to NFPA standards, they're all referenced in your OSHA requirements. But basically, if you have combustible dust present in fine enough particles, you have basically the three elements of the fire triangle in a wood shop. You have oxygen, which is always present. You have the fuel, which is your sawdust or wood dust. And then all it takes is an ignition source, which could be a spark from one of your processes, maybe a bearing on a cutting wheel or something. It could be a nail making its way through a saw, and that has the potential to make its way into your baghouse, your ductwork, and start a fire. Again, that's one of the two big risk factors. The other one is explosion risk. So when you have that same fuel or sawdust, which is then dispersed, so it's airborne, and then it's confined, so that could be confined in the baghouse or in your ductwork. Then you have all five elements for a potential explosion. So that's when the NFPA requirements for explosion venting, isolation, spark detection, and extinguishing come in. So it's important that if you have a wood shop, you're aware of your combustible dust being present. You do a dust hazard analysis. You bring in someone who's familiar with NFPA requirements to help you design a system that's going to be compliant and, most important, safe. So for the next section, I'm going to hand off to Dominic Dal Santo, and he's going to talk about system design for woodworking.